Hello, everybody. Today, we're going to take a look at how data is manipulated in the CPU. So last time we met in class, we talked about how data is represented um, as a bit, which is a 0, 1 in the various medium, either magnetic, optical, CDs and DVDs. Magnetic is a hard drive, and as on flash, it's represented as the presence or absence of charge. In a memory in a computer, it's represented as the presence or absence of voltage. So that's representing data. Today, we're going to look at how data is manipulated. So I'm going to show you the PowerPoint and sort of highlight some of the things that you're going to need to know for the test. So here is the PowerPoint that you guys have available to you in Blackboard. So this is all about data manipulation. So what we're going to focus on is really how the central processing unit works. That's the focus, how the CPU works. So the rest of these are not sort of general and not specifically covered here. So really the focus for today is how the CPU works. So first of all, the general CPU, and this is not in modern CPU, which has much more complicated than what we're doing here, but the basic components or sections of a CPU are three. First, the arithmetic logic unit. This is important. This is where arithmetic is performed like addition. Simple addition of binary numbers is performed in the arithmetic logic unit. The control unit is kind of the gatekeeper to the CPU. It determines when an instruction comes in from memory, this control unit determines where it should go. So it examines the instruction and determines where it should go. Should it go to the arithmetic logic unit? Should it go to perhaps somewhere else on the motherboard? And finally, we have some registers. Registers generally are just temporary storage areas for small amounts of data, like a couple of bits, could be 2-bit register, 16-bit register, your machine, 64-bit registers, and so on. So there's basically, we have registers, which is storage. We have the control unit, which determines where instructions should go. And then we have an arithmetic logic unit. All that's on your test. So memory is connected to the CPU through what's called a data bus, which is a series of wires that carries a single bit, either a 0 voltage or a 1, I'm sorry, a 0 no voltage, or a 1 which is voltage. So an instruction executes through a cycle of events known as, and this is important, this is on your test, fetch, decode, and execute. So this happens over and over and over and over and over again, hundreds of million times per second, very fast. So first of all, the fetch means a instruction travels across the data bus from memory and comes over to the CPU. And the first stop is the control unit. Once it's fetched, then it's decoded by the control unit. In other words, the control unit looks at the instruction, oh, this is some sort of an addition instruction, so it should go over to the arithmetic logic unit. And then finally, the instruction is executed. And that means the bit pattern, the 2 bit patterns are added together if it's an addition problem. Pixel lights up if it's headed over to the, perhaps a board that controls display or whatever. So everything happens real fast, millions of times a second. So this little diagram shows you have an instruction. This is a 16-bit instruction that travels across the data bus through the fetch and heads over to the control unit. And then the decoder, the decoding process is handled by the control unit. So the control unit says, oh, that instruction should head over to the arithmetic logic unit. And then in the arithmetic logic unit, circuits then execute that instruction. So that instruction might send some data over to a register temporarily or whatever. Okay, so arithmetic instructions are adding, subtracting, multiplying, dividing, perhaps a bunch of other things. So I'm going to skip ahead a little bit, things that you don't need to worry about. You don't have to worry about logical instructions. So this particular register is something that is important, and it's just one that I'm pointing out to you. So this is one example of a register. It's called the accumulator. So the accumulator basically stores intermediate results of arithmetic operations. So for example, if you're trying to add 7 plus 5, memory can only hold the 7. Where's the 5? The 5 is in this register. So 7 plus the 5 that's in the register, added together, that gets you a 12. And then again, we need to store that result somewhere. It has to go somewhere within the CPU because it may be used again. So the 12 then might be stored in this register called the accumulator. So the accumulator simply holds on to results of arithmetic temporarily before they're used for something else. So as far as your exam goes, what I just went over are the highlights and the important stuff that you need to know. The rest of the things on here is background information, and it's not something that will be covered on the test. So I'm going to stop the recording and we'll do one tomorrow.